We are entering an era where AI agents simultaneously attack, defend, and repair the software they live in. The battlefield is no longer just code. It is the autonomous logic that manages it. This raises a difficult question. Can an AI system capable of both breaking and fixing software improve our security, or does it simply create a faster path to automated harm? The shift is driven by a change in economics. The financial cost and physical effort required to launch a cyber attack are plummeting, allowing adversaries to operate with unprecedented scale. Human-led security teams cannot keep pace. Defenders are buried under a volume of alerts that execute at machine speed, leaving them reacting to events that have already concluded. Microsoft's Project Perception is an architectural attempt to resolve this. It is a system built to meet machine-speed attacks with machine-speed defense. Relying on human reaction times is no longer viable. The modern battlefield demands a system that is autonomous, continuous, and agentic. The defense begins with a new cyber stack. Raw signals are translated into an organized security context. Within this, red team agents actively pathfind and predict potential routes an attacker might take. Blue team agents investigate those pathways, reasoning over the environment to isolate meaningful risk. Finally, green team agents apply corrective actions, rewriting code to seal the identified vulnerabilities. An overarching agent harness coordinates these three operations into a closed-loop system that is constantly learning and improving the organization's posture. System actuators then translate these autonomous decisions into concrete protections, applying them across identities, applications, and clouds in real time. This multi-agent loop eliminates manual lag. It transforms passive security alerts into active machine-speed defense. Supporting a 24/7 security mission requires more than raw intelligence. It requires an engine that can operate at scale without prohibitive costs. Project Perception uses a multi-model architecture. By matching the right model to the exact task, it optimizes both reasoning quality and operational expense. We see this in software vulnerability management, where the MAI Cyber1 Flash model operates inside the MDASH agent environment. On the industry-leading CyberGym benchmark, this configuration scores 96%. That score is 12 points higher than the competing Mythos model. This performance comes with 50% cost savings compared to current market configurations, making high-tier protection economically sustainable. These capabilities are moving into the real world quickly, with Project Perception entering public preview on August 3, 2026. Effective AI defense relies on making continuous protection affordable. If the defense isn't scalable, the intelligence of the model doesn't matter. The speed-enabling autonomous patching also makes these systems dangerous. If hijacked, an attacker could weaponize the very tools meant to protect the network. Risks like indirect prompt injection and intent breaking could allow an adversary to seize control of the agent's reasoning engine. To mitigate this, every agent is treated as an isolated microservice. By applying a least privilege design, the system limits what any single agent can see or do. The ultimate safeguard is deterministic logic. High-risk actions are funneled through mandatory human-in-the-loop checkpoints. While the agents can plan and propose a solution in seconds, they cannot execute a production change without a human explicitly authorizing the action. This architecture protects against external threats while containing the blast radius of the autonomous agents themselves. The next era of cyber warfare is defined by this balance, harnessing machine speed while refusing to surrender human control.